Hello everyone, you're once more welcome to my science world. Today we shall be looking at an organic chemistry question, an IGCSE problem from the paper 42 of a June session, okay? That's June 2022. So when you go to June 2022, paper 42, question 6, you'll find a polymer question there, and that's what we're going to be looking at. The question goes thus. The question is about polymers, like we said. We come down. Polymer X is a condensation polymer. Part of the structure of polymer X is shown, and you have that. How many molecules of water are produced when this part of polymer X is formed from its monomers? The first question here is, what is a condensation polymer? Now, what do we understand by a condensation polymer? It is one, or it's a large, you can say a condensation polymer is a large complex. Okay, so you're going to have a large complex molecule formed when smaller, you can say smaller molecules called what? Smaller molecules called monomers are joined together, okay? Joined together. Now the keyword, one keyword is with the loss of a smaller molecule. With the loss of a smaller molecule. And that smaller molecule could be water, or better still, it could be hydrogen chloride gas. Okay? So that is a condensation polymer. Large complex molecule form when smaller molecules called monomers are linked together with the loss of a smaller molecule like water. When we look at that polymer again, we'll find something. We're going to find what? A kind of linkage. Now, this linkage is an ester linkage. So this is an ester linkage, and we have 3 of them. We have 3 ester linkage, and each ester linkage what produces a water molecule. So if we have 3 of them, then we're going to have what? 3 water molecules being produced. Is that okay? So the answer here is what? How many molecules of water? We can have 3 molecules of water produced. Is that okay? Now, if you want us to go deeper into that, now look at this. This is what this monomer is coming from. This monomer is coming from. Can you see that? And this other monomer is a diol. This other monomer is a diol. Let me show you what I'm talking about. So you're going to have this. So what is lost here? This is the water molecule is being lost. Can you see that now? So when your water molecule is being lost, then you're going to have what? Ester linkage. So that's what is written up here. You're going to come back to that. Can you see that now? So that is ester bond formed, which is similar to what we have on the question. And of course, for the production of that ester bond, you're going to have what? A loss of a water molecule. That's that. Good. So we move to the second part, Roman 2. complete the structures of the two monomers. That's easy. The first one was a dioic acid. So you're gonna put. Now, did they say show all of the atoms? So if they say show all of the atoms, then you're gonna have this. So a dioic acid, and this other one is a diol. So this is a diol. Good. That's a diol. So this is diol, and this is dioic acid. You can call it a dioic acid or a dicarboxylic acid. Dicarboxylic should be right here. So that's dicarboxylic acid. You could also have another monomer there. Instead of a dicarboxylic acid, sometimes you will find what? A diol, right? You're going to find a diol. Now, what do I mean by that? You're going to find this. Let me use a different thing. I'm going to take this color. What's this color? Violet. Let me take a violet pen. So you're going to have, so instead of an OH, you're going to have a chloride atom there, or a chlorine atom there. So this is a dichloride. And if this monomer is used, then instead of a water molecule being lost, you're going to have what? An HCl being lost. So take note on that. These are the different monomers you could use for that condensation polymer. So we go to Roman 3. What type of condensation polymer is X? What type of condensation polymer is X? So are you going to look at that? Now, what is that polymer X again? Look at it. We said it had an ester bond, an ester linkage. Can you see that? So if it has an ester linkage and many of them, then it becomes a polyester. Okay, so it becomes a polyester. We go back to our blue pen. So that's a polyester. Now your homework will be, I want you to give me the other type, another type. Give us another type of a condensation polymer. Okay, so I want you to go to the comment section and write down another type of condensation polymer. Thank you. So just write the answers in the comment section and we're going to deliberate on that. If you're right or wrong, you can maybe state some examples of what that other type. And you could also give us what? And a good example of a polyester. These are IGCSE questions, which you're gonna find. We move to the B part. It says, part of polymer Y has the structure shown. Now, part of polymer Y has what? The structure shown. State the number of different types of monomer needed. Now, how many types of monomer are here? Let's come up here first. We see that there are two types of monomers. So this polymer has two types of monomer. You can see that. So even from the boxes, they're different. Now, you can see from the functional groups, they're also different. So it has two types of monomers. So this polyester had two types of monomer, but your polymer Y should have, look at the monomer. For example, this is one monomer. Okay, this is the first monomer. It has, on the left-hand side, there is a carboxylic functional group. On the right-hand side, you're going to have a hydroxy functional group. And likewise, the same thing here. The same, a carboxylic and An alcohol functional group, a carboxyl. So it has just one type of monomer. One type of monomer. So these are special cases of what? Condensation polymer with one type of monomer. And that is also a trick whenever they're asking you the differences between a condensation polymer and an addition polymer. Most students will say, addition polymers have one type of monomer and condensation polymers have, different types of monomer. There are some condensation polymers with just one type of monomer, and this is a clear example. So that's usually what a hydroxycarboxylic acid. A good example is lactic acid, and that gives you what? A polylactic acid. Polylactic acid, right? So when you move to the, I think A2, you're gonna see that. We're gonna solve that. Now let's go to something else. Part of polymer Z has a structure shown. Part of polymer Z has a structure shown. Draw and name the structure of the monomer. Draw and name the structure of the monomer. How are we going to solve this? The easiest way is to what? Identify one repeat unit. So that's my one repeat unit. There's another repeat unit. So there are about 3 repeat units on this polymer. Secondly, on one repeat unit, all I need to do is attach a double bond. And that's my monomer. That's my monomer. I can come here and draw the monomer. So it becomes, of course, the monomer becomes an unsaturated hydrocarbon. And we have that. That's it. But the question says, show all of the atoms and all of the bonds. So I'm going to repeat that structure. So I'm going to draw now. I don't know why they asked that, but they just want you to be focused. Okay. And we can name this butene. Butene. Since the functional group, the carbon-to-carbon double bond is on carbon atom 2. I can beautify this by doing what? Just writing. I just wanted to draw it that way so that it should look like this. But a smart student will just, give us this. A smart student will just give us this. Is that okay? So that's that. And we have this. So that's butene or 2-butene. Okay, 2-butene, 2-butene or butene. That's that. Next question says, name the chemical process used to make the monomer that forms polymer Z. Name the chemical process used to make. What's a monomer? What's that monomer? Monomer Z is, the monomer of this polymer Z is an alkene, right? So what chemical processes or what chemical process produces an alkene? An alkene like butene, what chemical process? A good chemical process is cracking, okay? So cracking can do the job for you. When you crack large molecules, what's cracking? The breakdown of what? Breakdown of large, or less useful, you can say less useful, or what? Less volatile hydrocarbons. to what? Smaller hydrocarbons, which are more volatile and more useful. Okay, which are more volatile and more useful. More useful. That's it. That is that about that question. I hope you now have a clearer picture of polymers. It's an easy chapter, and hopefully we're gonna upload more videos on this organic chemistry and other questions of other topics as well. So thank you for your time, and please drop your comments on whatever you don't understand as far as this question is concerned, or if you have any other question that relates to organic chemistry or polymers in general, just drop them on your comment box and we're going to solve them for you. We're going to produce more videos like this, and that will help you ace your subjects. Thank you and have a wonderful day.